Hi, welcome back to this class. This is about analysis of algorithm, and the topic is number of spanning trees. We will try to explain what spanning trees and how it can be used, what are the applications. A minimum spanning tree, MST, is a tree that connects nodes in a connected weighted graph. So we have a graph and it is connected or and weighted. So we will consider that graph to have possible, smallest possible total age without having cycles. So let me go through the graph. What's graph? Graph is a set of vertices or nodes connected by edges. Weighted graph, each edge has its own cost, has its own weight, depends, and this weight can be represented as a distance or time or price. Spanning tree is a subset of the graph or subgraph or subset of the graph, which connects all nodes but having no cycles, no loops, and which can have exactly v minus 1 edges. V is the number of nodes minus 1, so you will get total number of edges. So minimum spanning tree among all possible spanning trees, it has the lowest total weight. So you might have a lot of spanning trees, a lot of subgraphs, but when we talk about minimum spanning tree, the subgraph that has the lowest distance or the lowest price or the lowest edge or the lowest total cost. Now, this is the graph, and you can see A to B is 4, A to D is 5, the weight, and B to D, the weight is 1, and C to D, the weight is 3, A to C, the weight is 2. Actually, this is an indirected graph because there's no direct arrow that goes from here to here. So this is, we call it indirected graph, and we can explain in the future, in the future classes, what's directed and indirected graph. So A to B was 4, A to C was 2, A to D was 5, B to D was 1, that is 1, and C to D is 3, that is 3. Now, so selected edges, for example, A to C, that is 2, C to D, that is 3, this one, and B to D, that is 1. So if we sum them up, 2 plus 3 plus 1, their weights, then we have 6. That is minimum possible total cost. So what are the properties of minimum spanning tree? Connects all nodes, all vertices, doesn't have any loop, contains v minus 1 edges, and it has minimum total edge weight. If all edge weights are different, then MST, minimum spanning tree, is unique. Now, there are two common algorithms for finding MST. It is Kruskal algorithm, Joseph Kruskal's algorithm, which sorts all edges by increasing weight, and at smallest edge that does not create a cycle, and continue until v minus 1 edges are selected. However, there's another one, Robert C. Prim's, starts from any vertex, repeatedly add the smallest edge that connects the current tree to a new vertex, and continue until vertices are included. So you stop when you included in the graph all nodes, okay? Applications, we can use it in computer communication networks. We can use it in railway. We can use it in power distribution networks. We can use it in water and gas pipeline design, and we can use it in machine learning, in particular in clustering, and we can use it finally in image segmentation. Now, a minimum spanning tree connects all nodes with no cycle while using the smallest possible total edge weight. So thank you very much. Stay tuned for the next classes regarding this topic. Thank you. Take care.